All right, dilations. Here's the intro. Why do we need to worry about dilations? Dilations are where we see a figure get bigger or we see that figure get smaller. If the figure gets bigger, we call that an enlargement. If it gets smaller, we call it a reduction. Either way, there is a scale factor involved with each of these. All right, so when we look at a dilation is a type of translation that changes the size, not translation, transformation. Yeah, we'll just cross that off. It's a type of transformation that changes the size of a figure without changing its shape, right? So dilations can make a figure larger or smaller. For example, here, figure got bigger, here, figure got smaller. Still a triangle, still a triangle. Doesn't mean that they change shape, right? So in a dilation, the original figure is called the pre-image. The dilated figure is called the image. The figures that are dilated from a fixed point called the what? What do we call it? We call it from the center of dilation. Or I'm going to refer to it as COD. Right? So this center of dilation occurs. When you dilate a figure, right, and as you can see, we have pre-image, image. Okay, in this case, my figure got bigger from the center of dilation. When you dilate a figure, the scale factor, if I can spell, good thing this isn't spelling class, right? S-C-A-L-E, scale factor, determines how much smaller or larger the image will be. Here's something to pay attention to. Notable bullet points. Bullet points are like, hey, I need to pay attention to these. If the scale factor is between 0 and 1, the image is smaller than the pre-image. Dilations with a scale factor between 0 and 1 are called a reduction, as mentioned before. If the scale factor is greater than 1, the image is called an enlargement. When a figure is dilated, you can name each point using a prime symbol, okay, with an apostrophe essentially. For example, the dilated image of point Q would be Q prime or red Q prime. Why is that? We have to distinguish between points. Okay, if you're talking about the same figure, same letter in both points, which one's first, which one's second? The prime notation tells me that. Fun fact, I didn't know anything about math was fun, but a pre-image and its dilated image are similar, which means that corresponding angles have the same measure and corresponding sides are proportional. Because of this, dilations can be classified as similar transformations. All right, so similar transformations. Moving on, how do we dilate an image about the center of the origin? It's pretty simple. This here goes and says, dilating figures by a scale factor greater than 1 makes them larger, so enlargements, and our scale factor here is 5. So I want to make this image 5 times the size. First, write the locations of points Q, R, and S. I'm going to follow the directions. So Q, negative 2 and 2. R, positive 2 and 2. S, negative 2 and 1. Dilate each by a scale factor of 5. I want to make this triangle 5 times the size from the origin. How am I going to do that? It's pretty simple. Every X and Y value gets dilated by 5. Minus 2 times 5 equals negative 10. Slash, there is my work for my X value. Where Q prime is going to be, negative 10. 2 times 5 equals 10. So Q prime goes to negative 10 and 10. Lots of other 2's up here. Well, gee, if 2 times 5 was 10, and 2 times 5 is also equal to 10, and 2 times 5 is also equal to 10, then R prime is going to be located at 10 and 10. Again, all I'm doing is showing my evidence as to what's happening here. Points S, negative 2 times 5 equals negative 10, slash, that's my x value. Again, x's are all over here, y's are all over here. 1 times 5 is equal to 5, so S prime is negative 10 and positive 5. Now I can go back and I can figure out where did those points go on my map. And I just plot them. Negative 10, positive 10. That is Q prime. Positive 10, positive 10. There is R prime. Negative 10, positive 5. There is S prime. Go ahead and connect my dots. Right there. Figure got 5 times the size. Right? That should be evident. This is 1. This is 1, 2, 3, 4, 5. 5 times the size. Reductions. I want to reduce this figure. This figure should be a fourth of the size, centered at the origin. Well, we're going to do exactly like we did before, only we're going to reduce it instead of enlarge it. So wherever you want to start, well, here it says R, so I got to start with point R. R is at negative 8 and negative 8, negative 4. S is at 4 and negative 4. T is at 4 and 8. And U is at negative 8, positive 8. So all these points are going to map to, that's what the arrow means, map to, RSTU prime by a scale factor of a quarter. So minus 8 times a fourth. What is a fourth of negative 8? Well, a negative times a positive is a negative, so my answer is going to be negative. And you're sitting there going, I don't know how to multiply negative 8 times 1/4. Sure you do, because negative 8 actually is a fraction. Make it a 1. We established that it's already a negative. 8 times 1/4. Well, gee, 8 over 4 becomes 2, so it's negative 2. Or if you cross cancel here, 4 goes into 4 once, 4 goes into 8 twice. You get negative 2. Either way, you get negative 2 as an answer. Okay, so there's your x value. What is negative 4 times 1/4? Apply the same principle. Negative times a positive is negative. A fourth of 4 is 1. So my point R prime, its new home is going to be negative 2 and negative 1. And I simply do the same thing for all of the other points. Show your work. No work, no credit. So the other points should be, go ahead and pause for a second, and I'll give you the values. Did you pause? You probably didn't pause. 1, negative 1. We should have 1 and 2, and we should have negative 2 and 2. And you should have found all those points. So now we can go back and we can figure out where those are. Negative 2, negative 1, that is R prime. And label your points as well. 1 and negative 1, there's S prime. 1 and 2, T prime. Negative 2, positive 2. There is U prime. Go ahead and connect your dots. And hey, I did something wrong. This is a good example. Where did I mess up? Because all of my points should be parallel. Right and lefts are, but the top isn't. So I messed up somewhere. Where did I mess up? It's either U or T. It's one of the two. So go back and look. Negative 2 and 1. So negative 2 and 1, that's correct. All right? S should be at 1 and negative 1. That's correct. It's parallel with the bottom. Okay? T and U. Well, T should be at positive 1 and positive 2. There is T. I think I just put that one in the wrong spot. And negative 2, positive 2. Yes, I put it in the wrong spot. So I just made a mistake when I plotted my points. But I caught my mistake. Okay? So there is when it is dilated at the center. Right? It's pretty basic, pretty easy. Follow that. And then now I'll give you a couple of questions, help with a couple of questions on your paper here on the homework that we did. And I think I did the first one on the front page and I did one on the back page. So here's how we're going to do this. Dilation of 3 about the origin. We don't need to draw lines and do all that crazy stuff. We could, but we don't need to. Hij. So I'm going to go with H, I'm going to go with I, and I'm going to go with J. And obviously you can write smaller and you have more room in your paper. I'm writing larger so I can see this. But where is H? H is at 0 and -1. I is at -1 and +1. And J is at 1 and 0. This is a scale factor of 3. So everything gets multiplied by 3, right? So if everything gets multiplied by 3, where are these going to go to? Now I ran out of room here. Okay, this isn't going to go over on number 2, but where is H prime going to move to? H prime times 3 is going to move to 0 and -3. I prime is going to move to -3, 3, and J prime is going to move to 3 and 0. Now, I've shown my evidence of where everything goes. Now I just have to label it and connect the dots. So, label it. 0 and -3. H prime. -3, +3. I prime. 3 and 0. J prime. Connect the dots. Done. Figure blew up by 3. Next page. The reason why I wanted to cover this, and this one's still here. The reason why I wanted to cover this, which I'll go ahead and just, let's see. I will go ahead and I will get rid of that, just in case you are worried about it. But the reason why I'm showing this one is because it says it's a dilation of a half, a fraction. Doesn't matter. I'm still going to find Hij, or GHI. So G, H, I, and J. And I'm just going to kind of do this on both sides here. So G is at -2 and 2. H is at 0 and 3. I is 3 and 0. And J is 0 and -3. My scale factor is a half. For all of them, my scale factor is a half. So they're all going to move over to here. Where is G prime? What is G prime's going to, well, take a half of that. Half of -2 is -1. Half of +2, +1. H prime. Half of 0 is 0. What's a half of 3? 1.5. You're absolutely right. So that ought to make I prime relatively easy. 1.5 and 0. And J prime, should make that look like a prime, not some funky new letter. J prime is going to be at 0 and -1.5. Now just plot your points. Think about it. It got smaller, right? It should be inside this figure. So 1, -1, there is my G prime. 0, 1.5, so 0, 1, and 0.5, there's my J prime. 1.5 and 0, so 1.5 and 0, there's I prime. And J prime is at 0 and negative, oh, I did this backwards because mine's a little bit different. I did J on the bottom, so J prime 0, -1.5. I missed my -1, +1. That should be my H, and that's not right. H, 0 and 1.5. 1.5. There it is. So G, I did this different on the board than I did on most. GHIJ. Actually, no, I didn't. GHIJ. So -1 and -1. H, I skipped H on my paper is what I did. Oh, erasers don't write. H prime. Again, I know I messed up because, one, I plotted the point in the wrong spot, which wouldn't have made it corresponding sides parallel. So there's 2 examples. You have 5 more to do on this page. I want a total of 7. All right, so between these 2, you should have a total of 5. Make sure you get those in there. All right? Ask questions if you need to.